When implementing redundant ISPs for failover on a Cisco router, it's pretty cut and dry every time. You configure an IP SLA probe to ping a well-known IP address out there on the internet, used to track the state of the primary ISP, link that IP SLA probe to a tracking object, and configure your two static routes. The primary would be tied to the tracking object, and the secondary would be configured with a higher administrative distance. The idea here is that if the IP SLA probe does not receive a response to the ICMP echo request it's sending out, then it goes down, along with the tracking object, which then causes the primary ISP's default route to be withdrawn from the routing table and replaced with the default route pointing to ISP2. Pretty straightforward, right? Well, yeah, seems like it, except for the fact that I left out one very important step. The reason I intentionally left out a step is because of a question that I've received several times on my dual WAN videos, which is why I'm making this video. The question pertains to whether or not it's actually necessary to add a specific route for the address you're tracking via IP SLA, even if you configured a source interface or source IP in the IP SLA configuration. For example, let's say we configured an IP SLA probe to ping 8.8.8.8 in order to track the state of ISP1. How does the router know which interface to send those pings through? I mean, if we're tracking ISP1, it makes sense that this would only work if the pings were sent out of the interface connected to ISP1 and only that interface. But how can we ensure that this happens, though? Well, the solution lies within the question I've been asked in my dual WAN videos. To answer it, yes, it is necessary to add a specific route, or preferably a route map for local policy routing for the address you are tracking via IP SLA. This is the only way to ensure proper and reliable tracking of your primary ISP. Configuring a source interface or a source IP for your IP SLA monitor doesn't affect routing. It simply defines the source address for the ping, and that's it. The routing table is what makes the forwarding decision for those ICMP packets. So if you configure only a source interface or source IP for IP SLA without paying attention to routing, those ICMP packets can, and eventually will be, forwarded egressed from a different interface than intended, leading to unpredictable behavior in your ISP failover setup. That said, I'm going to take you to my ISP failover lab over here in GNS3, where I have intentionally left this step out so I can show you a few examples of what can go wrong and why when this is left out of the configuration. All right, let's go ahead and take a look at this lab. The first thing you'll notice is that it's very simple. We have a basic run-of-the-mill network with a router connected to two internet service providers labeled ISP1 and ISP2 respectively. And I've already configured the router right here for ISP failover. So let's go ahead and take a look at the configuration on the router really quick for the failover configuration. So here are the two static default routes for ISP1 and ISP2. As you can see, ISP1's route is tied to track 1, and ISP2's route has a higher administrative distance. Now let's go ahead and take a look at track 1. So we see that track 1's up and down status depends on IP SLA 1. So we'll go ahead and check that as well. So as shown here in the IP SLA summary, we see that IP SLA 1 is configured to ping 8.8.8.8. And that is how we're tracking the state of ISP1. But remember, I left out a specific route to 8.8.8.8 to demonstrate the failover behavior. All right, so let's get into this. For scenario 1, we have two issues. First, as mentioned, there's no specific route to 8.8.8.8, and the second thing is that we have a lazily configured NAT ACL. So let's just take a quick look at that. All right, so we see this permit any, And this is a quick way to do it, but it is not the correct approach by any means. Unfortunately, I see this often on customer routers. So if this is you right here, stop. Stop doing it like that, for the love of God. But anyways, let's see how our failover behaves with a misconfigured NAT ACL and the lack of that route to 8.8.8.8. And just to show you, we are currently using ISP1. Show IP route. Our default route is going out to ISP1's router. And we do have connectivity. Yep, perfect. So we're on ISP1 and we have internet connectivity. So now let's go ahead and disable ISP1 to simulate a failure and see what happens. Here we go. So we went down. Check this out. Now we're back up. And then we're going to go back down. And then back up. So what in the world's happening with this? This seems extremely inconvenient because if we want a reliable internet connection, this doesn't seem to be the way to do it, because we're flapping back and forth between ISP1 and ISP2, even though ISP1 is down. See, we're on ISP1. I'm sorry, ISP2. Now we're back on ISP1. Once that goes down again, we'll be back on ISP2. And this is going to happen over and over and over again until either ISP1 actually comes back up or it's manually corrected. So if I were to go IP route 8.8.8.8, and then set the next hop specifically to ISP1's router, this flapping back and forth will stop. So now we're down, and we're going to remain on ISP2 at this point. But why? What's happening? Well, let me tell you. And also, let me take this route back out of here so it doesn't affect our further examples. So the flapping is going to start once again. But the reason this is happening is because, well, first of all, we don't have a specific route to 8.8.8.8. When the IP-SLA monitor is sending out those ICMP echoes, where are they going to go? There's no specific route, so this is the best matching route, which is our default. So when we're on ISP1, or when ISP1 is up, those IP-SLA monitor pings are going out the correct interface, and they're sourced with the IP address from ISP1. I'll show you. So they're sourced with the IP address 47.225.64.50, but that doesn't have anything to do with routing. So when ISP1 goes down, the default route, we'll wait till it goes down again. Once this goes down, boom, the default route changes over to ISP2 via 27.30.100.1. So what do you think's happening to those ICMP echo requests destined for 8.8.8.8 now that our default route changed? Well, they're going out the interface for ISP2. Then, with the addition of NAT being configured wrong, NAT is translating the source from the IP address of ISP1 to the source of ISP2. So just to get this flapping back and forth to stop, I'm just going to bring ISP1 back up really quick here. And let's go ahead and take a look at the NAT translations. See, we're going out to 8.8.8.8. Our inside local is 47.225.64.50. That is the IP address that we have assigned ourselves for ISP1, and NAT is translating it to 27.30.100.50. So those ICMP echo requests sent from our IP SLA monitor are essentially just going out to ISP2 sourced from 27.30.100.50, the IP address we've been assigned for ISP2. So goes out to the internet through ISP2, and then comes back. Our router gets a response from 8.8.8.8, assumes that ISP1 is back up. Then once the default flips over back to ISP1, those are going out the interface connected to ISP1, but then of course ISP1 is still down, so it goes down again because the IP SLA probe doesn't get a response. And then the same thing happens over and over again. Back out to ISP2, and then comes back up, and then flaps back over to ISP1, goes down, back over to ISP2, comes back up, back over to ISP1, over and over again. So that brings us to scenario 2. Let's go ahead and correct the NAT access control list. So I'll take out no permit any, and I will configure it the way it's supposed to be configured, which is supposed to be specifically. So if you see down here, we have this little network just consisting of 2 PCs, but this is on the 192.168.1.0/24 network. This is the only subnet that I would want translation to happen on going out to either of the ISPs. So we'll configure that like that in the ACL. And remember, I removed that specific route to 8.8.8.8 as well. So now the only thing we have different is our NAT configuration has been fixed. So let's go ahead and suspend ISP1 again and see if that stopped the flapping back and forth. Okay, so we're down, as we should be. We're on ISP2, we have connectivity. Nothing in the NAT translation, so that's good because we fixed that NAT statement, and we're not flapping back to ISP1. So it seems like it's working. So you might be thinking at this point, well, just fix your NAT statement, and everything's fine, right? Well, not quite, because even though it's not flapping back over to ISP1 and then back to ISP2 and back and forth, those ICMP echo requests are still being sent out the interface connected to ISP2. There's just no NAT happening on them. And I can show you that. Let me bring over the router for ISP2 and take a look at what's happening if we go debug IP packet. Check this out. See this? Destination 8888, source 47.225.64.50. So the same thing is still happening. These packets generated from our IP SLA monitor are still forwarded out of the interface connected to ISP2 when ISP1 is down, We're just not translating the source address to the IP address assigned by ISP2. So what's actually happening, the only reason this is working is because this this ICMP echo request generated from our router, from our IP SLA monitor destined for 8.8.8.8, is sourced with 47.225.64.50. And remember, what I said earlier when I first started the video has nothing to do with routing. It's just now going out gig 0/1 to ISP2, but still sourced with the IP address for ISP1. So that ICMP echo request is being forwarded to ISP2. ISP2 is forwarding it out to the internet. When 8.8.8.8 responds, it's going to send it back through the internet and then to ISP1 because this address belongs to it. But since ISP1 is down, that ICMP echo reply is never going to make it back to a router. So this works, but again, it's not the right way to do it. We don't want any of our IP SLA probe ICMP packets going out any other interface except for the one that we're intending to track, which in this case is ISP1. But that also brings me to a third example, and that is some ISPs actually block IP address packets sourced with IP addresses that don't belong to them, or something that doesn't belong to the customer. So you see on this segment right here, for ISP2, we have the IP address 2730.100.50, and even though it's not filled in here, I made it a /24. So the 2730.100 defines the network, and then the last octet defines the host. So if ISP2 operated in a way where it blocked packets sourced with an IP address other than anything containing 27.30.100, then we have another problem without that specific route on our router to 8.8.8.8. So let me go ahead and bring ISP1 back up, which it should come back up, no problem. While we're waiting on that, let me go ahead and jump over to ISP2 and kind of just simulate ISP2 blocking packets sourced with different IP addresses. Okay, let's go back over to our router and make sure that ISP1 actually came back up. And it did. Do show IP route. Yep, back on ISP1. But now that ISP2 is blocking packets sourced with different IP addresses, let's see how the failover works now. So we'll go to our router, wait until we see this go down, and then we'll go over to ISP2's router and see what it looks like from that perspective. Show IP route. So failover worked. We're on ISP2. We do have connectivity. But let's go take a peek over here at ISP2. We see that we're still receiving packets sourced from 47.225.64.50 destined to 8.8.8.8, and we see access denied because of the that access control list. So those ICMP echo requests sent from our IP SLA monitor on our router destined for 8.8.8.8 are still being forwarded to ISP2. ISP2 is blocking them. Like I said, some ISPs will do that. Well, how does that affect failover? Well, we're not flapping back and forth. It seemed to fail over to ISP2 like normal. But here's the problem with this scenario. Let me show you. Let me bring up ISP1. And in the meantime, what do you think is going to happen? I'll give you a hint. Remember, without that specific route to 8.8.8.8, the only thing that packet has to rely on to get out where it needs to go is the default route. And even though this has been the case the whole time, you saw the two other scenarios and why it was working and why it would flip back over to ISP1. But why do you think it's not flipping back over to ISP1 now? I mean, we just enabled it and we're still waiting. So remember the last scenario? It was making its way through ISP2 to the internet, back down to ISP1. Or the first scenario when NAT was translating this source and then changing it to the IP address of ISP2. ISP2 is now blocking packets sourced with IP addresses that weren't specifically assigned to that customer. And now ISP1 is never going to come back up, as far as in the routing table that is, because those packets are just being discarded. So with all of that being said, whether it be scenario 1 with the NAT misconfiguration, scenario 2 when we fixed NAT, or scenario 3, which is this one right here where your ISP blocks IP addresses that that don't belong to it, things get messed up with our failover every single time because we don't have that specific route. So basically all of this, I'm taking this deep dive and giving you all of this to show you exactly why we need a specific route to the IP address that we are pinging through IP SLA to track our primary ISP. So let's go ahead and just fix it really quick. So instead of going IP route 8888 and then setting the next hop, I like to create a route map and then configure it as a local policy. Reason being is because if we just stick IP route 8888 in here, all traffic from the rest of the network that hits this router destined for 8888 will only go out the interface for ISP1. And 8888 is actually one of Google's DNS servers, so we would effectively take down a path to 8888 in the event that ISP1 went down, because that route would be sitting in the router's routing table, and then any packet going through the router, the router's data plane traffic would look at that route and then try to send it out that interface. So a better way to do it is to create a route map, set it as a local policy that only affects the router's control plane traffic, or its self traffic. And it's very simple to do this. I start with an access list. Say IP access list extended. I'll name it something simple. IP SLA 1. Permit ICMP any, which this doesn't really matter because it's going to be applied to the router itself, so that doesn't really matter. So permit ICMP any to host 8.8.8.8. Route map, we'll name the route map the same, IP SLA 1. Permit 10. Match IP address, IP SLA 1. Set IP next hop, and then let me grab that IP address for ISP1's router. So set IP next hop 47.225.64.1. IP local policy route map, IP SLA 1, and now ISP 1 should come back up. Perfect. There's our route map, IP SLA 1. And we see that it is policy routing those packets. And like I said, this route map configured as a local policy only affects the router's control plane traffic. If any of these hosts down here were trying to communicate with 8888, that would be routed normally, depending on whatever default route was in the routing table at that point, depending on if ISP1 was up or down or what was going on. So this route map does not affect data plane traffic whatsoever. Anyways, that's about it. I did my best to take kind of a deeper dive into this. Like I said, I've received several questions on my dual WAN videos on if this is actually necessary to create a specific route for that IP address that your IP SLA monitor is pinging. And I just thought, you know what? I'm just going to go all out, make a video, show every single example that I can possibly think of on how your failover, or should I say the reliability and the performance of your failover is going to suffer if you do not configure a specific route for that. So with that said, I really hope this helps. And if you have any questions, leave a comment in the comment section below, or you can send me an email directly to rob@rmtechcentral.com. And yeah, that's about it. I'll see you later.